My humble salutations to my beloved Bhagavan, respected elders, and my dear students. Hearty welcome to special functions class. So today now we are going to continue with the Rodrik's formula of Legendre polynomials. So that Pn of x equal to 1 by 2 power n factorial nth derivative of x square minus 1 whole power n. Now we know that y is equal to, if we take x square minus 1 whole power n, now differentiate with respect to x, then what is going to happen? dy by dx equal to n into x square minus 1 whole to the power of n minus 1 times 2x. Again this becomes thank you. So we are having on the right hand side x square minus 1 whole power n minus 1. So when you bring that down, it becomes n times x square minus 1 whole power n into 2x whole divided by x square minus 1. That we are going to take it on the left hand side. That becomes x square minus 1 into dx equal to n into x square minus 1 whole power n into 2x. So the right hand side becomes now 2nxy. Now if we are going to differentiate this on both sides with respect to x n plus 1 times. N plus 1 times. With respect to what? With respect to x we are going to differentiate. So when you differentiate with n plus 1 times, we apply Leibniz formula. What is the Leibniz formula? If you are having u and v are two functions, then the product uv, if we are going to differentiate it for n number of times, then the formula becomes u times nth derivative of v plus nc1 times first derivative of u into n minus 1th derivative of v plus so on. Similarly, when you are going to differentiate for n plus 1 number of times, it becomes n plus 1 of x square minus dy by dx equal to right hand side becomes 2n is a constant that comes out n plus 1 derivative of x. So what is this value? X square minus 1 it is n plus 1 derivative of dx plus n plus 1 first derivative of this d of square minus 1 times n derivative of dy plus n plus 1 d square of x square minus 1 times d power n plus 1 that becomes d power n plus 1 divided by. Now what is there on the right hand side? 2n times x into n plus 1 derivative of y plus n plus 1 first derivative of x into n plus 1 minus 1 becomes nth derivative of y. Okay. So Leibniz theorem apply chesi manam chestunnamu. So this becomes x square minus 1 into n. Already we have differentiated ones. Afterwards, we are differentiating successfully n plus 1 number of times. Totally how many times we are differentiating? N plus 2 times we are differentiating. So this becomes derivative of n plus 2 of y plus what is n plus 1? Nothing but n plus 1 into derivative of x square. What is it? X into and then already n times we are differentiated and 1 times. That means totally n plus 1 number of times we are differentiated. So derivative of n plus 1 by dx power n plus 1 plus what is n plus 2? N plus 1 and divided by 2 factor into what is the second derivative of x square minus 1? 2. So 2 into nth derivative by dx. So 2 gets cancelled On the right hand side becomes now 2nx into n plus 1 derivative y plus 2n into n plus 1 into 1 into n derivative of y. So finally, x square minus 1 plus n derivative of y with respect to x plus 2 into n plus 1 into x into n plus 1 derivative of y plus n into n plus 1 into derivative of y that is equal to 2nx into n plus 1 derivative of y with respect to x plus 2n into n plus 1 into n derivative of y with respect to x. Now this becomes x square minus 1 into n plus second derivative of y with respect to x plus 2nx into n plus 1 derivative of y with respect to x plus 2x times n plus 1 derivative of y with respect to x plus n square into derivative of y plus 10 into derivative of y with respect to x plus 2nx into n plus 1 derivative of y with respect to x plus 2n square into nth derivative of y with respect to x plus 2n times nth derivative of y with respect to x. So this becomes x square minus 2 times n plus second derivative of y with respect to x plus 2x into n plus 1th derivative of y with respect to x minus of n square plus n times nth derivative of y with respect to x. So finally we conclude 1 minus square taking the minus square 1 minus square times second derivative of y with respect to x minus 2x plus 1 derivative with respect to x plus n into n plus 1 times derivative of y with respect to x equal to put d square y by d square that this becomes 1 minus square times d square square minus 2x into n plus 1 times 0, which is the Legendre differential equation. So finally it's given by that is equal to CPM of x where C is a constant. So what is that? Nth derivative of that. So how do you write? D power n by divided by dx power n by C times dx power n. So d power n by dx power n. So d power n by dx power n x square minus 1 power n square minus 1 power n of x. Now in this x is equal to 1, then it becomes CPM at part 1. That becomes CPM of 1 equal to 1. So right hand side becomes equal to C1. So we can write nth derivative of x square minus 1 whole power n at x equal to 1 equal to it can be written as how do you write x minus 1 x minus 1 into so nc naught x minus 1 naught n into n minus 1 whole power n into n plus nc1 into x minus 1 whole power n minus 1 whole power n minus 1 of x plus 1 whole power n plus so on ncn into ncn plus 1 whole power n. So all the terms equal to 1 if we substitute all the terms at 1 we get the last term that is ncn equal to 1 n factor into 1 plus 1 whole power that becomes n factor into 2 power n. So c is equal to 2 power n into n factor. So nth derivative of square minus 1 whole power equal to 2 power n into n factor into n of x. Thus n of x is equal to 1 by 2 power n factorial. Nth derivative of x square minus 1 plus n. So this is Rodrik's formula. I hope that is clear. Another important formula that we have done, generating function for PMLs. In the expansion of 1 minus 2nz plus z square, whole to the power of minus half in power subject. It can be shown the coefficient of z power n is hence 1 minus 2x z square whole to the power of minus half is called generating power n of x. So how do you write? 1 minus 2x square plus minus half is equal to summation p n to the power n. So in order to do this, first of all, recollect that you know that 1 minus x whole power minus x equal to plus nx n into n plus 1 square plus n into n plus 1 divided by x cube plus so on. When n is equal to half and x is equal to t, the above equation can be written as 1 minus 10 to the power of minus half. So that is nothing but 1 plus half into t divided by 1 factor plus half into half plus 1 divided by 2 times t square so we are applying binomial theorem. So what is this binomial theorem? Just now we have discussed 1 minus x whole power minus 7. So if we are going to have 2 minus, we are going to get all plus only. 1 plus nx plus n into n plus 1 by 2 factorial times x square plus n into n plus 1 into n plus 2 divided by 3 factorial times x cube plus 1. Instead of x, we are replacing x by t, replacing n by half. So that becomes 1 plus half into t plus half into half plus 1 divided by 2 factorial times t square plus half into half plus 1 into half plus 2 divided by 3 factorial into t cube. What is going to be the next term? Half into half plus 1 into half plus 2 plus half plus 3 divided by 4 factorial times t power 4 and so on. So on further simplification, this becomes 1 plus half of t plus 1 into 3 by 2 into 4 t square 1 into 3 into 5 divided by 2 into 4 into 6 whole to the power of t cube plus 1 into 3 into 5 into 7 divided by 2 into 4 into 6 into 8 times t power 4 plus or 1 into 3 into 5 etc. 2n minus 1 divided by, in the denominator we are getting all even terms. What are the even terms? 2, 4, 6, 8 and so on to n times t power n. So the left hand side now is 1 minus 2x z plus z square whole to the power of minus half equal to, how we can write 1 minus z times 2x minus z whole to the power of minus half. Now 1 plus 1 by 2 times variable. What is this variable? Z into 2x minus z plus 1 into 3 divided by 2 into 4 times variable square. What is the variable? Z times 2x minus z. So whole square means z square into 2x minus z whole square plus next term we are going to get product of 3 odd numbers in the numerator. Similarly, we are going to get product of 3 even numbers in the denominator. 2 into 4 into 6 into variable cube, that is z cube into 2x minus z whole cube plus next term 1 into 3 into 5 into 7 divided by 2 into 4 into 6 into 8 times variable power 4. What is the variable? Z. Z power 4 into 2x minus z whole power 4 plus so on 1 into 3 into 5 etc. 2n minus 5 divided by 2 into 4 into 6 etc. 2n minus 4 times z power n minus 2 into 2x minus z whole power n minus 2. That means we have taken n minus 2 power term. Similarly, n minus 1th term. What is that? 1 into 3 into 5, etc. 2n minus 3 divided by 2 into 4 into 6, etc. 2n minus 2 times z power n minus 1 times 2x minus z whole to the power of n minus 1 plus 1 into 3 into 5 into etc. 2n minus 1 divided by 2 into 4 into 6, etc. 2n times z power n into 2x minus z whole power n. But x minus a whole power n, what is the expansion of this binomial expansion? Summation. Alternatively, we are going to get plus minus plus minus. So it becomes minus 1 power r into ncr into x power n minus r into a power r. Now the coefficient of z power n in this equation is nothing but 1 into 3 into 5, etc. 2n minus 1 divided by 2 into 4 into 6, etc. 2n into z power n into 2x minus z whole power n. Okay. So this can be written as 1 into 3 into 5, etc. 2n minus 1 divided by 2 into 4 into 6, etc. 2n into z power n into summation minus 1 power r ncr into 2x to the power of n minus r into z power r. Now that can be written as z power n into, further expand this term on the right summation. The first term is nc naught 2x power n minus nc1 into 2x power n minus 1 into z plus so on. So that is nothing but 1 into 3 into 5, etc. 2n minus 1 divided by 2 into 4 into 6 into etc. 2n into what is nc naught? That is nothing but 1 only. So 2 power n into x power n minus n into 2 power n minus 1 into x power n minus 1 into z plus so on. So the z power n coefficient in the last term is 1 into 3 into 5, etc. 2n minus 1 whole divided by 2 into 4 into 6, etc. 2n into 2 power n into x power n. Next term becomes z power n plus 1. After that, z power n plus 2, like that we get. So we consider only z power n term. Now this is nothing but 1 into 3 into 5, etc. 2n minus 1 divided by 2 power n into n factorial we can write. Because 4 can be written as 2 into 2, 6 can be written as 2 into 3, and 2n can be written as 2 into n. So if you take 2 common in each term, n terms are there, 2 into 2 into 2 like that, n times. That becomes 2 power n into n factorial. And this becomes 2 power n into x power n. That is nothing but 1 into 3 into 5, etc. 2n minus 1 divided by n factorial times x power n. Similarly, what do you expect the coefficient of z power n, the previous one? So we are going to write 1 into 3 into 5, etc. 2n minus 1 divided by 2 into 4 into 6, etc. 2n minus 2 times z power n minus 1 into 2x minus z whole power n minus 1. So that is nothing but 1 into 3 into 5, etc. 2n minus 1 divided by 2 into 4 into 6 into 2n minus 2 into z power n minus 1 times n minus 1 c naught 2x power n minus 1 plus n minus 1 c1 times 2x power n minus 2 z plus n minus 1 c2 into 2x power n minus 3 times z square and so on. So the coefficient of z power n in the last but before term in the previous equation is nothing but 1 into 3 into 5, etc. 2n minus 1 divided by 2 into 4 into 6, etc. 2n minus 2 into this becomes minus n minus 1 c1 2x to the power of n minus 2. This term and this term. Okay. So that is nothing but minus comes out. 1 into 3 into 5, etc. This. Okay. So multiplying and dividing in numerator and denominator with n into and 2n minus 1, and simplifying we get this particular solution. So this becomes okay. Similarly, the coefficient of z power in the term in the last term is given by. So finally, we conclude this is nothing but Pn of x. So thus, in the expansion of 1 minus 2xz plus z square whole to the power of minus half, I have nothing but P1 of x, P2 of x, P3 of x, etc. Pn of x are coefficients of z, z square, z cube, z power n respectively. Thus, 1 minus 2xz plus z square whole to the power of minus half equal to summation Pn of x into z power n. Okay. So, ఈ విధంగా we conclude the generating function of Legendre polynomials. This is also an important question. So, please keep it in your mind. I'm going to stop it here. Thank you.